Hello guys, welcome once more to another video in our YouTube channel. So in today's video we are going to be looking at the solutions of the first 20 questions that featured in the Lycee Bilingue Etoug Ebe mock examination of 2022 Pure Maths with mechanics / with statistics. So for those of you who are just joining us, endeavor to subscribe to the channel, like the video, comment on the video, and share the video links with your friends. Alright, so let's get started. Okay, so we have the first 4 questions displayed to us. So what we are going to do is that we are going to solve every question and we take the correct answer with their justifications. Alright, so question 1 reads, the exact value of logarithm to the base 4 of 8 root 2 is. So logarithm to the base 4 of 8 root 2, we are going to use the properties of logarithm. We are going to use the identity for what this logarithm means, and then we try to verify if our final response is going to be in the options. So logarithm to the base 4 of 8 root 2 is simply logarithm of 8 root 2 divided by logarithm of 4. Now we know that 8 is 2 cubed and root 2 is 2 to the power half. 4 is 2 squared. Now we are multiplying 2 cubed and 2 to the power half. They have the same basis, so we add the powers. So we have 3 plus half, it gives us 7 on 2. Now we apply the properties of logarithm by sending the power to multiply the logarithm of 2. We do the same for the denominator. The logarithm of 2 cancel, and then at the end we get 7 divided by 4. So for question 1, option C is correct. Now let us move on to question 2. It reads, given that f of x equal to sine x for x in interval 0 to pi, the value of x that satisfies the Rolle's theorem is. So what is the Rolle's theorem first of all? Now it says that if a function is continuous over an interval ab, let me try to so we have an interval ab, a closed interval first. So if the function is continuous in this closed interval, and then the first thing is that the function is supposed to be continuous in this interval, in the closed interval. Now the second thing is that the function is supposed to be differentiable in now the open interval. So continuous in the closed interval, differentiable in the open interval. So the first, continuous in the closed interval; second, differentiable in the open interval; third, if the function is f, then considering our first interval, f of a should be equal to f of b. So these are the 3 conditions. So if the function is continuous in the closed interval, differentiable in the second interval, and f of x and f of a is equal to f of b, then we can conclude that there is going to exist a constant. Let's say the constant is c in our interval. I can just call that interval I. So we are going to have a constant in this interval, such that when you take the derivative of the function, the first derivative of my function, and I impute that constant, I'm going to get 0. So this is all about the Rolle's theorem. So first of all, we verify if this function satisfies the Rolle's theorem in this interval. Yes, it does, because sine x is both continuous and differentiable in the open and the closed interval from 0 to pi. F of 0 is equal to f of pi, so the third condition is satisfied. So since these 3 conditions are satisfied, then there's going to exist a constant in the interval a to b, such that f prime of that constant is 0. So guys, we are going to use this to now get the value of that constant, or the value of x for which this function satisfies the Rolle's theorem. Alright, so from the Rolle's theorem we have that since our 3 conditions have already been satisfied, we have that there is going to exist a constant c in the interval 0 to pi, such that f prime of c is equal to 0. So what is f prime of x? Is simply differentiating sine x, you get cos x. So it means f prime of c is cos c. Now f prime of c equal to 0 means that cos c is equal to 0. So we can get the general solution. Our c will give us 2k pi plus or minus pv. Pv is the principal value, which is cos inverse of 0, that is pi ln 2. Now if we let k to be 0, we are going to have c to be plus or minus pi ln 2. But we are dealing in the interval 0 to pi, so the negative solutions are going to be eliminated, so we are going to be left with c equal to pylon 2, and that is the only solution in this interval such that cos c is equal to 0. So we can conclude that c equal to pylon 2 is the correct answer. So option C is correct. Now let us move on to question 3. It is on partial fractions. It reads, the partial fractions of 2x on x minus 1 times x squared plus 4x plus 4 is. So the first thing is that we identify x squared plus 4x plus 4 as a perfect square, which is x plus 2 all that squared. So after doing this, now we can now verify the various options. So we are going to have a constant over the linear factor plus a constant over the first linear factor here plus a constant on the second linear factor all squared. So option B and option C are correct. So option D is going to be correct because B says you have A over a linear factor plus B on x plus 2 then plus C on x plus 2 all squared. It is equivalent to option C because D, E and F are also constants. I can take the negative sign and attach to E and I call it B. It is still a constant. So option C says D on x minus 1 minus E on x plus 2 minus F on x plus 2 all squared. It is similar to option B. So we are going to take option D being correct since option B and option C are both correct. Alright, we move on to question 4. An example of an irrational number is, so the first thing is that we are going to simplify all these options. So sine pylon 2 is sine 90, which is 1. Sine 3 pylon 2 is sine 60, which is root 3 on 2. Sine pylon 6 is sine 30, which is half. And sine 5 pylon 6 is sine 150, which is half. What is an irrational number? I'm going to give you the properties. The first thing is that the number of decimal places are infinite. Second is that it cannot be expressed in the form of a fraction, meaning you cannot have it in the form a divided by b, where a and b are integers. The third is that numbers like pi, e are normally irrational numbers. So when we look at this, we see that option B is the only irrational number because not expressing it as a fraction, we have number 1, option A can be expressed as 1 on 1, yes. Option C, this is a fraction 1 on 2. Option D is a fraction 1 on 2. But option B, you see that it is expressed as a fraction, but now the numerator is not an integer, the numerator is a square root, which is an irrational number. So automatically root 3 on 2 becomes an irrational number as well. So option for question 4, option B is correct. Alright, let us move on to question 5. It reads, the axis of symmetry of the curve of y equal to x squared plus 3x is. So we are going to plot we are going to consider a quadratic equation, a quadratic function y equal to ax squared plus bx plus c, and we are going to consider a to be positive because dwelling with our equation, the coefficient of x squared is 1, which is positive. Anyways, the rule holds even if a is negative as well. So we are going to plot the general we are going to plot ax squared plus bx plus c. Let's just choose any graph, right? So here is a plot of ax squared plus bx plus c. Now what is this axis of symmetry? It is simply an axis that will divide our curve into two equal parts, and normally we clearly see that the only axis or line that is going to divide this curve into two equal parts is a vertical line. Now, and that vertical line will normally pass through the turning point, because at the turning point the function here is minimum. So if you pass a line through the turning point, then the left hand side of the graph of the function will be equal to the right hand side. So what is our turning point? We can say the x coordinate is x0 and the y coordinate is y0. How do we get the turning point? Now we see that the line x0, the line x equal to x0 is the axis of symmetry, since it gets the graph into two equal parts. Now at the turning point we need to get this x0. We know at the turning point the derivative of our function is 0, the first derivative. Now if we differentiate ax squared plus bx plus c, we are going to get 2ax plus b. We equate to 0, we find the value of x, so x is negative b on 2a. So the x coordinate of the turning point is negative b on 2a. So we can conclude that the axis of symmetry is a line x equal to negative b on 2a. Now according to our quadratic function I was given, we have y equal to x squared plus 3x. We compare and we have our a to be 1, the coefficient of of x squared, and our b to be 3, the coefficient of x. So it means the axis of symmetry is x equal to negative b on 2a, which is negative 3 on 2. So option B is correct. Alright, let us move on to question number 6. It's on limits. We are finding the limit as x tends to 0 of the ln of cos 2x divided by 7x squared. So the very first thing to do when finding the limit is you try to substitute the value where x is tending to and see where the limit is tending to. So we fit x to be 0. We see this limit tends to ln of cos 0 divided by 7 times 0 squared, which is 0. Now the cos 0 is 1, the ln of 1 is 0. So at the end we have this limit tending to 0 on 0. This is an indeterminate form, so we apply the L'Hopital's rule. The L'Hopital's rule says that whenever the limit gives you an indeterminate form, the identity of this, the equivalence of this limit will be the limit of the derivative of the numerator divided by the limit of the derivative of the denominator, the first derivatives. If you have an indeterminate form again, you continue the differentiation process. So we are going to differentiate the both numerators separately. So this limit is the same as the limit of the differential of the numerator divided by the differential of the denominator. How do we differentiate the ln of cos 2x? We differentiate cos 2x and we divide it by itself. Differentiating cos 2x gives us negative 2 sine 2x, then we divide it by cos 2x. We now differentiate 7x squared as well, we get 14x. Please, in this question, when you're looking for the limits by L'Hopital's rule, you don't do quotient rule. You differentiate the numerator separately and you differentiate the denominator separately. Alright, so this limit now we are going to simplify. Sine 2x divided by cos 2x is tan 2x. Now from 14 I can factor out a 7, and then my negative 2 in the numerator I can also factor it out. So the numerator, you have negative 2 on 7, then the limit as x tends to 0 of tan 2x divided by 2x. But this is a standard limit and it gives us 1. So at the end, this limit gives us negative 2 divided by 7. So option A is correct. Alright, let us move on to question 7. It reads, given that mu e is greater than 1 and e is between 0 and 1, the precise range of mu is. So we have the information that mu e is greater than 1. So we first of all find mu. We divide both sides by e. Dividing both sides by e, we get mu is greater than 1 on e. The inequality sign remains greater than because our e is in a positive region. Remember, we don't divide both sides of an inequality or multiply if we don't know the sign. But now, since our e is positive, then our inequality sign remains greater than. Now, our mu is greater than 1 on e, and e is between 0 and 1. So we have a little worry here because we need to get the exact range of mu, but it is not in terms of e. So if mu is greater than 1 on e, we just need to verify the exact range of 1 on e, then automatically it becomes the exact range of mu. So since e is less than 1, according to our definition here, I'm just considering this upper portion. E is less than 1, it means that 1 over e will be greater than 1. Let me prove it. If I have two constants, or if I have two numbers which are positive, a and b, such that a is less than b, a less than b means I can divide both sides by b, and since b is positive, the inequality sign remains less than, and b as well is not equal to 0. So a divided by b will be less than 1. I can multiply both sides of the inequality by 1 over a, and since a is positive, then 1 over a will be positive. The inequality sign will still remain less than because we are multiplying by positive. So a on b times 1 over a will be less than 1 times 1 over a. So at the end, we get the left hand side to be 1 over b and the right hand side to be 1 over a. If 1 over b is less than 1 over a, it means that 1 over a is greater than 1 over b. So you see that a less than b means 1 over a is greater than 1 over b. It is the same case here. E is less than 1, so 1 over e will be greater than 1 over 1, and 1 over 1 is 1. So we now also know that if you have a relation of two numbers, for example, that are real numbers, a greater than b, the relation that relates the two numbers is that a is greater than b. This relation is said to be transitive. That is, if a is greater than b and b is greater than c, then automatically a is greater than c. So we apply the same rule here. We have that mu is greater than 1 over e and 1 over e is greater than 1. So we can conclude that mu is greater than 1. So option B is correct. Alright, so we are moving on to question 8. It reads, the expansion of 2x plus 1 divided by 2x minus 1 times 2 minus 3x is valid for. So I'm going to convert this expansion as 2x plus 1 times. I'm going to send everything in the denominator to the numerator. Now we are going to look at the condition for validity of an expansion. So generally, if I have the expansion a plus bx to the power n, this expansion will be always valid if the magnitude or the absolute value of bx divided by a is less than 1. So we are going to look for the validities of every expansion here, and we intersect those validities on the number line to get the validity of our expansion. So here 2x plus 1 is already expanded, so it is always valid because 2x plus 1 cannot be expanded again because it is already in its expanded form. Now 2x minus 1 to the negative 1 is the first expansion here. 2 minus 3x to the negative 1 is the second expansion. So we are going to get the validities of these two expansions. We take the intersection of those validities on the number line. The result will give us the validity of our given expansion. So let us begin with the expansion 2x minus 1 or negative 1 plus 2x. I wrote it this way because I want it to resemble a plus bx. So we clearly see that our bx is 2x and our a is negative 1. So bx of a becomes negative 2x, becomes 2x on negative 1, which is negative 2x. So we set the absolute value of negative 2x to be less than 1. It means that the absolute value of 2x is less than 1. We can divide both sides by 2. We get the absolute value of x less than half. We solve the inequality. We get that x is between negative half and half. Now we get the validity of the second expansion, which is 2 minus 3x to the negative 1. You see that our b is negative, our bx is negative 3x and our a is 2. So for it to be valid, the absolute value of negative 3x on 2 should be less than 1. We have the absolute value of x to less than 2 divided by 3. So we solve and we get x between negative 2 on 3 and 2 on 3. Now the validity of our given expansion is the intersection of the validity of our sub expansions. So we go to the number line and we try to demarcate these intervals. So the first interval is from let's say negative 2 on 3 right up to 2 on 3. We are going to have it here. So this is negative 2 on 3 and then this is 2 on 3. Since the interval is open, we can shade. But anyways, let's plot the second. Let's now plot for negative half to half and see what we get. So the second is from negative half to half. Negative half is here and then half is here as well, because half is 0.5 but 2 on 3 is 0.6. So here we have from negative half right up till half, but we need the intersection. So we see that for the first validity, this is the interval that's from here to this region. Here is the interval. Now for the second validity, here is the interval from here to here. Where do they intersect? They intersect in this region. You clearly see that from negative half to half, it is a subset of the from negative 2 on 3 to 2 on 3. So it means the intersection is from negative half to half. So option A is correct. Alright, let us move on to question 9. It reads, the exact value of the sine of 105 degrees is. So remember that we are not going to use a calculator, so we are going to express 105 degrees into the sum or the difference of standard angles. So 105 degrees can be written as 60 plus 45. Those are two standard angles. So the sine of 105 degrees is the same as the sine of 60 degrees plus 45 degrees. From the identity, that's from the expansion of sine A plus B, we have the sine of 60 times the cosine of 45 plus the cosine of 60 times the sine of 45. The sine of 60 is root 3 on 2, the cosine of 45 is 1 on root 2, plus the cosine of 60 is 1 on 2 and the sine of 45 is 1 on root 2. So we can have root 3 on 2 root 2 plus 1 on 2 root 2. The denominators are common, so we just add up the numerators. So it means that sine 105 degrees is exactly equal to 1 plus root 3 divided by 2 root 2. So option A is correct. Now we are moving on to question 10. It reads, given that 6 plus 5 cos theta plus pi on 2 lies between 1 and 11, where theta is a real number, the theta coordinate for the maximum value of 6 plus 5 cos theta plus pi on 2 occurs is... Alright, so if this function is maximum, it means that it is actually equal to 11, because 11 is its maximum value. So for the function to be maximum, then we just equate the function to 11. We can now subtract 6 on both sides, and we are going to get 5 cos theta plus pi on 2 to be equal to 11 minus 6, which is 5. We can now divide both sides by 5, and we get cos theta plus pi on 2 to be equal to 1. Nevertheless, if a function is maximum, then the individual parts of the function have to be maximum. In this case, we have the function 6 plus 5 cos theta plus pi on 2. 6 is already 6, so it is at its maximum state. What about 5 cos theta plus pi on 2? Now we have the product of two functions. 5 is a constant function, so for 5 cos theta plus pi on 2 to be maximum, then cos of theta plus pi on 2 should be maximum. Now when is the cosine of any angle maximum? It is maximum, that is, the maximum value is 1. So it means that our f here, which is 6 plus 5 cos theta plus pi on 2, is maximum when the cosine of theta plus pi on 2 is maximum. Now the cosine of theta plus pi on 2 has a maximum value of 1. So we can look for the general solution. We get theta plus pi on 2 to the 2n pi plus or minus pv. The pv is cos inverse of 1, which is 0. So we can subtract pi on 2 on both sides, and we get theta to be 2n pi minus pi on 2. We can look for the LCM, and we get theta to be 4n pi minus pi, all divided by 2. We can factor out the pi, and then we get the correct response as option C. Alright, question 11. Which of the following functions is continuous at x equal to 2? So you have different functions, and they have the same definitions for the intervals, if x different from 2 and if x equal to 2. So let us begin with what it means by saying x is different from 2. X is different from 2 means that we have all real numbers excluding 2. So we take all numbers that are less than 2 alongside all numbers that are greater than 2. Now, if a function is continuous at a point, there are two things. The limit of the function at that point exists, and that limit is equal to f of that point. We are saying that if the function is continuous at x equal to 2, then the limit as x tends to 2 of my function exists, and that limit is equal to f of 2. If you look at the second definition, the second intervals for all the options, it is if x equal to 2. So if x equal to 2, it means that f of x is equal to 6. Therefore implies that f of 2 is equal to 6, because if x is 2, then f is 6. So f of 2 is equal to 6. Here it is 7, here it is 5, and here it is 2. Anyways, we now dwell ourselves on the limits. If the limit of a function exists, it means that the right hand limit is equal to the left hand limit. Right hand limit, it means x is tending to 2 from above, and left hand limit, it means x is tending to 2 from below. Alright, so for the first function, we see that the limit as x tends to 2 is 2, because the limit as x tends to 2 from below, we are using the function x, and the limit as x tends to 2 from above, we are still using the function x, because f of x is equal to x provided x is not equal to 2, meaning that x is less than 2 and x is greater than 2, but different from 2. So we see that the limit as x tends to 2 from above and below of this function is simply 2. So the limit as x tends to 2 of the function is 2. But what is f of 2? Our f of 2 is equal to 6, because when x equal to 2, the function is 6. So the limit giving us 2 and f of 2 giving us 6 means that the function is not continuous at 2. We need a case where the limit will give us a value and f of 2 will also give us the same value. Now for option B, we see that the limit is also 2, because we are using x, we just need to replace x with 2 to get the limit. But f of 2 is 7, so it is not continuous. For option C, the limit is still 2 and f of 2 is 5, so option is wrong. So the correct answer is option D, since the limit is 2 and f of 2 is 2, so the function is continuous. So it means option D is correct. Alright, we are moving on to question 12. It reads, the range of values of a for which the equation mx squared plus 5x plus 6 equals 0 has real roots. Now, since they said our equation has real roots, it means that the roots might be real and equal or real and distinct. For real and distinct roots, the discriminant is greater than 0, and for real and equal roots, the discriminant is equal to 0. So in a general case, for real roots, the discriminant is supposed to be greater than or equal to 0. Alright, so if you have a quadratic equation ax squared plus bx plus c equal to 0, if the roots are real, then our discriminant is greater or equal to 0, because the roots might be real and distinct or real and equal. For real and distinct, we have the greater than 0. For real and equal, we have the equal to 0. Since it was not distinguished here if the roots are real and distinct or real and equal, we take both cases. So b squared minus 4ac is greater or equal to 0. So our discriminant in our quadratic equation here is 5 squared minus 4 times m times 6. So solving, we get 25 minus 24m greater or equal to 0. We can add 24m on both sides. We divide both sides by 24 and then we reverse the inequality. So we have m is less than or equal to 25 divided by 24. So option C is correct. Alright, let us move on to question 12. The cotangent of theta plus pi ln 2 is the same as. So we are going to write the cotangent of an angle as the cosine of that angle divided by the sine of that angle. Now the cosine of theta plus pi ln 2 can be expanded, as well as the sine of theta plus pi ln 2 can be expanded. So we expand, you have cos theta cos pi ln 2 minus sine theta sine pi ln 2. Then the denominator is sine theta cos pi ln 2 plus cos theta sine pi ln 2. Cos pi ln 2 is 0, so it means that the first terms of both numerators gives us 0. Sine pi ln 2 is 1 and sine pi ln 2 is 1. So at the end, we have negative, because of this negative here, sine theta divided by cos theta. Negative sine theta divided by cos theta is negative tan theta. We can also recall that the tangent of theta plus pi ln 2 is negative cot theta. So option B is correct, negative tan theta, as we have here. Alright, question 14. Given that A, B, and C are invertible matrices, then ABC or that inverse is. Now how do we find the inverse of a product? We begin the multiplication from the extreme right. So it means ABC or inverse. We begin with C inverse, then we go to B inverse, then we go to A inverse. So option B is correct. So C inverse, B inverse, A inverse. Option B is correct. Now question 15. In logic, the logical statement the negation of P implies Q is the same as. So for this question, I'm not going to solve the equation, but I'm going to give you hints, and then you're going to give me your response in the comment section. So the hints I'm going to give you is that, firstly, we cannot negate an implication. What we do is that we convert the implication to a conjunction or a disjunction before we negate. So P implies Q is the same as not P or Q. So this is the equivalence of the implication. It is not P or Q. So it means the negation of P implies Q is the negation of its equivalence. How now do we negate not P or Q? Not P or Q is negated as we negate the not P, we negate or, we get an, and then we negate Q. Now when we negate in negation, we just get a statement. So it means the negation of P implies Q is the same as P and not Q. So you are going to verify these options here by converting them to the conjunction or the disjunction, and then you tell us your answer in the comment section. Alright, so we are rounding up. We are going to question 16. X plus 1 plus x minus 1 divided by x squared plus 1 is a result obtained by dividing two polynomials. The remainder is, so I'm going to give you guys a basic review about Euclidean division or long division where you're dividing two polynomials. So if I have two polynomials f and g, if I take f of x divided by g of x, how do I write it? I write the quotient, meaning the whole part, plus the remaining part divided by my divisor. So if you multiply all through by g of x, we are going to get that our f of x is equal to the whole part, which is the quotient q of x, times g of x plus sorry, this is supposed to be g, so let me just do the correction. So this is not q, this is supposed to be g. Alright, so we multiply both sides of the equation by the denominator of the left hand side. We are going to get our f of x to be equal to q of x times g of x plus r of x. R of x is a remainder. So let's have a basic review. If I want to do the long division of x plus 1 divided by x minus 1, I begin x divided by x. It gives me 1, which is my quotient already, and I'll multiply 1 times x minus 1 is x minus 1. I now do my subtraction. So I take x minus x, I'm going to get 0, and then I take 1 minus negative 1, I'm going to get positive 2. It means that x plus 1 divided by x minus 1, we write our quotient, which is 1, plus our remainder, which is 2. This 2 here is a remainder, then divided by the divisor, which is x minus 1. So it means that x plus 1 is simply 1 times x minus 1 plus 2, because when we multiply x minus 1 times 2 over x minus 1, the x minus 1 cancel, and we are going to be left with 2. Alright, so according to our result here, we can say our polynomial is f of x, and we are dividing by x squared plus 1, because you clearly see that x squared plus 1 is a divisor since it is found in the denominator. So you are going to get x plus 1, which automatically becomes our quotient, then plus x minus 1 divided by x squared plus 1. So it means that x minus 1 is our remainder when we compare. So the remainder is option B, x minus 1. Alright, question 17. The center of the circle is, so we are going to define the general equation of the circle. It's given by x squared plus y squared plus 2fx plus 2gy plus h equal to 0. Now the center of this circle is at a point with coordinate negative f, negative g. Now according to this, our equation that has been given, we see that the coefficient of x squared and y squared, they have the same coefficient, which is 4. But according to this, our general equation, the coefficients are supposed to be 1. So we need to divide all through by 4. Dividing all through by 4, we have that x squared plus y squared. 4 on 4 is, we now get minus x. 24 on 4 is 6, then plus 13 on 4. So we now compare coefficients. You see that 2fx is equal to negative x, so our f is negative half, and then 2gy is equal to 6y, so our g is equal to 3. So the center is at the point negative f, so negative of negative half is half, and then negative g, just negative 3. So the answer is A, half, negative 3. Alright, so let's move on to question 18. Question 18, I'm not going to stress the question 18, the answer is A. So if you face difficulties in simplifying this, you just let us know in the comment section. Alright, question 19. The greatest, this guy here means the greatest integer less than or equal to x. A function g of x is defined as g of x equal to the greatest integer of x plus x squared for x in the interval 2 to 3, where 2 and 3 are both included. Another way of defining this function is, so let me give you guys a brief review about the greatest integer function. So the greatest integer function is actually an integer, meaning that if I input a value of x here, the output is going to give me an integer. Now that integer is supposed to be less than or equal to my input, but it is the greatest integer that is less than or equal to my input, meaning that if I take, for example, the greatest integer of 2.1, the result is supposed to give me the greatest integer that is less than 2.1. There are so many integers that are less than 2.1. Integers are whole numbers. We have 2, we have 1, we have 0, we have negative 1. But the greatest of all those integers is the greatest integer of 2.1, which is 2. Another example, the greatest integer of 3.99 is the greatest integer of, that's the greatest integer which is less than or equal to 3.99. There are so many integers that are less than 3.99, but we need the biggest. Integers, for example, like 3, 2, 1 are less than 3.99, but the biggest of those integers is 3. So the greatest integer function of 3.99 is 3. Now let us come back to our equation. We need to get a new definition of the function g. We have the various options, so we are going to start by eliminating. Now we look at the options, we see that in all the options we have the second interval is if x equal to 3, then g of x is 3 for option A, g of x is 3 for option B, g of x is 12 for option C, and g of x is 12 for option D, and for option D x is equal to 2. So let us find g of 3, because here we see that if x is 3, it means that g of 3 is supposed to give us 3 for option A to be correct, and then we also verify for the first. So then let us look for g of 3. Our g of 3 is simply given by the greatest integer of 3 plus 3 squared. Now what is the greatest integer of 3? The greatest integer of 3 is the biggest integer that is less than or equal to 3. So it is just going to give us 3, because there is no integer that is less than or equal to 3 which is not 3, since we are looking for the greatest integer of 3. So the greatest integer of 3 is an integer that is less than or equal to 3. You see, since 3 is already equal to 3, then automatically the greatest integer of it itself. So the greatest integer of any integer is that integer. So 3 squared is 9, so we add up the 2, we get 12. So it means that we can eliminate option A, option B already. Now because for option A it says that g of 3 is 3, and option B says that g of 3 is 3 as well. Now option D has g of 2. Let us look for g of 2. G of 2 is the greatest integer of 2 plus 2 squared. Now what's the greatest integer of 2? It is 2. Then plus 2 squared, you are going to get 6. So we eliminate option D also. So it means that the correct option is option C. But why did we just take option C? What is the explanation? We have seen that the second part is okay, but let us justify why the first part is also okay. Now for the first part, it says that g of x is equal to x squared plus 2 if x begins from 2 and ends at 3, where 3x is excluded. Now from 2 to 3, you see that if we begin, for example, let's begin at 2, right? Let's begin at 2. We are going to have the greatest integer of 2 plus 2 squared. That's what we are going to get. Now if you go to 2.1, we are going to have the greatest integer of 2.1 plus 2 squared. But the greatest integer of 2.1 is still 2, then plus 2 squared. Okay. Now if you go to 2.3, for example, because it's still in this interval, we are going to have the greatest integer of 2.3 plus 2.3 all squared, right? So at the end we get the greatest integer of 2.3 is 2, then plus 2.3 all squared. So we see that the x squared remains x squared, but what is changing is just the greatest integer. So whenever we impute the greatest integer of any value here, the answer is going to give us 2, because that value is between 2 and 3, and 3 is excluded. So if you take the biggest number here, let's say 2.99999, if you take the greatest integer, you're still going to fall back to 2. Then you need to add the square to it. So at the end, we see that at the end you're still going to be taking x squared plus 2, because this greatest integer of any value between 2 and 3, where 3 is excluded, is simply 2. So that is why we are very okay that option C is correct. Now the last question is question 20. A function f defined from r plus to r plus, defined by f of x equal to x squared is, so is the function injective? Is it an odd function? Is it an even function? Or is it injective being odd and even? Okay, so let's see what we have here. Alright, so let's first of all define what an even function means. Let's verify the parity of this function. So let's look for f of negative x. F of negative x is negative x order squared, which will give us x squared, and x squared is c f of x. So we see that f of negative x is equal to f of x, so it means the function is even. Okay, now the function being even, we see option C. What about the injectivity of this function? We have the interval from r plus to r plus, meaning that we are dealing, the domain has only positive values of x. Alright, and the images, all the values of the images are also positive. So it means that For the functions with injective, we know that for an injective function, f of a equal to f of b means that a is equal to b. So I'm going to leave you guys to verify the injectivity of this function. So thank you guys for watching, and see you in the next video. The next video we are going to be solving from question 21 to question 35, and we are going to release the video tomorrow as well. So hope you guys enjoy the video. Tell us in the comment section.